Okay, today we are learning about Chapter 2, Lesson 3, which can be found on pages 93 through 98 in your textbook or online. Our objective for today is I can use powers and exponents in expressions. Vocabulary is base, cubed, exponent, power, squared. Question 1, what tells me how many times I need to multiply the base? Question 2, I can say that 32 is 3 to the second power, or 3 blank. Alright, I found this rap that'll hopefully introduce you to the terms a little bit more and help you remember them. So let's watch a little bit of it.
This one is for the students learning exponents. I will show you in a way so it just makes sense. When it comes upon the test, yo, don't be afraid. Listen to my rhymes and you'll be safe. The rules, they cool, don't be a fool. You just gotta listen to your teachers in school. It's time now to have some fun. If you raise it to a 0, then the answer is 1. Raise it to a 1 when the problem is a done. When you use a 2, I'll tell you what to do. Do you multiply the number by itself? You know, you just squared a number. If you feel my flow, you say, excuse me, what if it's a 3 or 4? I mean 5, 6, 7, or maybe something more. You just take the base, then look up high. The number is the times you need to multiply. Oh, yes I did. Somebody please tell me who the heck I is. I am this curve that hit the math up. Back will work up and chuck
Hey, we got the base multiplying away, showing how to write it another way. You can use that
Alright, let's go ahead and look at it in our book. So on page 93, it talks about base and exponent, and it shows you what that looks like. So here are our factors, and these 3 factors become our exponent. So base is what this factor is, 10, and our exponent becomes the number of times we multiply that 10. So 1, 2, 3 tens. So it's 10 to the third power, which is our exponent. So that's why down here it talks about powers. So it shows you in this graph over here, 2 with the exponent of 5 is the same as saying 2 to the 5th power. And 3 with an exponent of 2, that you can say that 3 to the 2nd power or 3 squared. And that's just like 10 to the 3rd power, or 10 with an exponent of 3. You can say it that way, or you can say 10 cubed. So the way this relates to what we were talking about with prime factorization is once you get those prime factorization numbers, let's say these are the ones you got 3 6s. So what you would do would be, when you write it out, 6 times 6 times 6, and then you would have to figure out how to write that as an exponent. So our base would then be the 6, and we'd look at how many times it was multiplied, 1, 2, 3, so it would be 6 to the 3rd power, or 6 cubed. Alright, to show you one more example of that, if you look at page 94, it shows you that tree we were working with in prime factorization. So I'll put the answers on. Let's see. So in this problem, if we're using prime factorization of 72, this is the tree they did. And they came up with these factors, and they put them from least to greatest. So this would be your steps, completing the factor tree, ordering them from least to greatest. And then you have to take those numbers, so we got 2s and 3s in this case, and you have to write them in exponent form. So 2 to the how many, let's see, 1, 2, 3, 2 to the 3rd power, or 2 cubed. And 3, we multiply that 2 times, so it's 3 squared, or 3 to the 2nd power. And then we would multiply these 2 answers. So it's kind of simplifying what we wrote out here. Alright, so let's look back at our questions. Question 1, what tells you how many times you need to multiply the base? And question 2, fill in the blank for that.